Hello and welcome to my talk. I'm Andrei Popescu-Belis and I'm going to present to you today a system for interactive poem generation. This is joint work with Aris Xanthos, Valentin, Àlex Atrio, Gabriel Luthier, and Antonio Rodriguez. And we are from the School of Management and Engineering of the Canton of Vaud and from the University of Lausanne. So, how creative can neural language models be? This is the main question we intend to explore with our system. In fact, we want to explore more generally artificial creativity through the generation of poems, which are considered as the type of text that most innerly express human creativity. But we don't want to design a system that simply generates poems according to a language model. We actually intend to let the user drive this system according to their own intentions. And we also want to experiment with the general public. And for that, the system actually is living its own life in a public exhibition. So it is in the Château de Morges, that is the Morges Castle, that is close to Lausanne and not far from Geneva either. The exhibition is called Code Poésie, or in English, Digital Lyric, and it has been public since Valentine's Day this year. The exhibition is supported by the Swiss National Science Foundation through the Agora program. The co-curators are Professor Antonio Rodriguez and Professor Sarah Kenderdine from EPFL, and the project itself has been granted the Optimus Prize from the Swiss National Science Foundation. So in a nutshell, how do we see the human interaction with the system for generating or co-creating poems? In the first stage, the human decides on the form that they wish to give to the poem. And the system then generates, using a language model, the first draft. Then the users are allowed to inflect the poem based on the topics they wish to see in the poem and their emotions they want to express. And for that, the system is able to adjust the poem in this direction, as I will explain. Finally, it is also possible to enforce a rhyming pattern and, using a rhyming dictionary, obtain suggestions from the system. In the exhibition, the poems are printed on a large plotter, and they are also immediately sent online to a website where the users can retrieve their own creations using a code. So let's start with the theoretical part of the model. So a quick reminder of neural language modeling. In fact, language models are simply probability distributions over words given previous words from the context. Neural language models use typically recurrent neural networks, and they have shown that if we consider characters instead of words, the generation is even more fluent and is able to account for some phenomena such as grammatical agreement. So we use a toolkit called TextGen-RNN built over TensorFlow, which has actually two recurrent network with recurrent layers with LSTMs, and an attention layer over a concatenation of the embeddings and the two bidirectional layers. So we have also some skip connections, as we see in the schema. And in the end, we have a softmax layer over the 89 characters of our vocabulary. So to train these language models, we used databases of French poetry from poesiefrancaise.com and from the project Gutenberg. We have a general language model trained over 340,000 lines of poetry, so that's about 14 million characters in French. And we have topic-specific and emotion-specific language models, which are trained over much smaller data sets because we need poems that are labeled with a specific topic and emotions. So here each model is trained on about 10 to 20,000 lines of poetry. The vocabulary are the French letters, including the accented ones, the punctuation, but for instance, not the digits, which we don't want to see in our poems. So the first stage starts, of course, by leveraging the general language model. And here we draw the next character according to the probability given by the model, but modified by a temperature factor, which is actually able to emphasize, in some cases, the probability of the highest scoring characters. So this makes the model a bit more conservative, or it can actually flatten the distribution and make the model more surprising or more creative. But in any case, we realize that the first lines that are generated, as they don't actually benefit from a large context, are of poor quality. So what we do is we generate about 4 lines of poetry in the background. We don't show them to the user, but we start the creation once this context is in place. So this improves quite a lot at the beginning of the poem. We also are able at this stage to constrain the form. In fact, our system can actually be constrained for any number of stanzas, verses, or syllables per verse. And while it is not difficult to constrain the number of stanzas or verses, it is more difficult to constrain the length because nothing in the language model is prepared for that. So we ask the language model to generate about 85% of the intended length, and then we try several endings until finding a natural one. As shown in the example below, the first 2 are quite spurious, but if we can get to "Shall I compare thee to a summer's day," then we're very happy. Of course, this verse is not from our system. We still need to clean the output. Our choice is to avoid generating unknown words, although sometimes they are very interesting, they're very creative. So we replace all unknown words with their closest match from a dictionary. We also clean the punctuation and manage the casing to start every line in uppercase. For the adjustment to topics and emotions, we have an adjustment algorithm. The reason is that we cannot actually restart the generation from scratch. So once we have set a form and we have a first draft, it is only possible to adjust it to some topics and emotions, but we cannot restart the whole generation. Otherwise, we lose actually what we did before, and the user is not happy to restart from scratch. So we select some of the words that do not fit the topic and or emotion specific models, and we replace them by querying the topic and emotion language models. We replace them with words that fit better these the probabilities of the language models. Finally, for the rhyming pattern, which again can be selected for the user, we actually use a French phonetic dictionary, and we select which line endings should change so that the rhyming pattern is enforced, and we replace them with words that rhyme and have a high probability from the language model. Now, this is the theory. Well, we still need quite a number of things to achieve objects that can be left for 3 months autonomously in a public exhibition. You can see here an image of our 3 installations. We have 3 copies of it. And indeed, we have some requirements for robustness, but also for transparency and explicitness. So the graphical interfaces of the systems are in the Kiwi framework, also in Python. We designed them to be self-explanatory. They are full screen on a touch screen. And once a poem is completed, they go back from the start. Everything is logged, and the users are given an anonymous identifier so that they can retrieve their poems online. So as soon as they are completed, they're sent to our web server. They can also be printed on a large plotter designed by David Héritier and Nicolas Baldron from the Center for Future Publishing, which you can see in the room. The press has been quite favorable. There have been a number of articles on the exhibition and some mentions of the system itself. And they emphasize the importance of the human and the gap that remains between the human intentions and the system's output. In fact, in our experiment, we never really intended to replace the human, but we wanted to blend the human and artificial creativity. And in this talk, I have evidenced the gap between the theory, which says just train a language model on poetry and generate poems, and then the reality of an operational system, which should be used by people. So obtaining a well-formed poem that reflects users' choices requires quite a number of technological solutions, which I have presented. Our system has generated tens of poems every day before the COVID lockdown, and our intention is also to analyze the creations in the future. So I will now demonstrate the system in the second part of this video. So this is the welcome screen. Actually, it is full screen on the touch screen in the exhibition. As I said, the first stage is to really flesh out the poem by simply indicating the form. Let's use a quatrain. The system now generates, actually on my own laptop here, a quatrain, a poem of 4 lines. And actually, the systems do not require a GPU in generation mode. They're sufficiently quick so that they can be run on a small form factor computer, which is in the exhibition. So we get here an example. It looks like a poem from the start. It even has some nice verses, like the third one, Le ciel bleu d'or, des feuilles et des fleurs. If you read French, it sounds like poetry, but it also has some strange things which we're going to edit in the following stages. We could also restart here from scratch if we wanted, or for instance, change, let's do it here, this for the verbal construction into a noun. So, pour le sourire, en deuil de l'air et de la vie. We're now offered the possibility to emphasize some of the topics. So we already see some options here in the poem. We see things related maybe to nature. So let's put something related more to love and a bit of nature. And we now ask the system to adapt this creation to the settings. We will see that the words that have been changed are underlined so that we can judge if we like these changes or not. Actually, we like them quite a lot, especially the first one, pour le sourire en extase, de l'air, and here we have la voyage, actually another verbal construction. Let's edit these things manually. Pour le sourire en extase, de l'air et du voyage, et tout le soir, dans le ciel bleu perdu. So we move forward. We could maybe actually emphasize a bit joy in this poem. So again, we move the cursor and we ask the system to adapt it. Now, let's see. Le ciel bleu de son, des fourrures et des fleurs. I don't actually like this very much, so I will actually put the models to 0 and get back to my first version. We move forward and we'd like this small poem to rhyme. So actually, let us try maybe the first pattern. So A, B, A, B. The first and the third verses should rhyme, and the second and the fourth one too. But of course, let us play with this suggestion. So indeed, voyage and avantage are very nice rhymes. Femme et madame are not that great, but maybe des choses, de la dame. Okay. at least now we have the rhyme. So we move forward to the phase which is related to the physical printing in the room. So the font actually can be selected by the user, as I'm shown here. This is work by David Héritier and Nicolas Baldron in the graphical aspect. And once this is finished, we can settle on this choice. So the poem goes to the printer, and we see a QR code which directs us to a website where the poem is actually uploaded. And actually a code which is not shown here is also given to users to to access their creation. Of course, another solution is just to take a picture with the smartphone. And once this is finished, or after some minutes of inactivity, we restart the demo. Now, of course, by now we have several dozens of poem creations, and our goal in the long term is to analyze the user behavior. For now, we see that people actually have tried to edit their poems. They have changed the initial proposal. And we would also like to provide some analysis of how poetical these creations can be seen. Actually, these co-creations between AI and people. So thank you very much for your attention. And if there is time, I will be ready to take some questions.